Well, hi guys and girls. This video is over partial fractions, and this is an advanced integration topic that's a little easier to see than the integration by parts is. And it's going to require just some mechanics for you to separate it into two easy fractions to deal with. And the whole idea behind this is to take a fraction in terms of x and break it down into two pieces. And the reason we're going to do that is because if we can separate it into two pieces, then they're really easy integrals. Okay, so let's take a look at how this is going to go down. All right, so that's the deal. Complex, well, it's not a complex fraction, but a fraction broken into two pieces. A couple of things you're going to notice is your denominator will always be a quadratic, and the numerator will not be the derivative of the denominator. So it's going to lead you to think maybe this is a natural log right off the bat. So let's take a look at one that is a natural log right off the bat. All right, this integral is 2x minus 1 over x squared minus x minus 6. I like purple. And we should know that the integral of u prime over u works out to be the natural log of the absolute value of u plus c. So if you see a fraction, that should be the first thing you should look for. And this integral is set up perfectly because if u is the bottom, x squared minus x minus 6, then u prime is 2x minus 1 dx. And this is a perfect u prime over u integral. So this would work out to be the natural log of the absolute value of x squared minus x minus 6. So if you see a fraction, the first thing you should look for is at u prime over u. And here it was perfect. Sometimes you might need to multiply through by a constant or something. You know, your du dx you might have to divide by 2 to make it work out. But what happens if we come across a problem where that's not possible? So here I have a fraction, and it's a quadratic in the denominator. So if we try our u prime over u, let's take a look at that. Then I get that du is 2x minus 1 dx, and you'll notice that there's no way I can turn 2x minus 1 into 3x plus 11. I can't multiply it by a constant, I can't divide through, I cannot solve this relationship right here for 3x plus 11 dx. That is when you are going to need to use the method of partial fractions. We're going to break this up into two separate integrals that have degree 1, and there's going to be two easy natural log integrals. So let me show you how this looks. So if we see that it's not perfect u prime over u, we are going to write down that 3x plus 11 over x squared minus x minus 6 can be factored into x minus 3 times x plus 2. And we are going to say that this can be turned into some fraction over that has a denominator of x minus 3 plus some other fraction that has a denominator of x plus 2. What we don't know is what numbers or variables go up here for a and b. Ah, that's messy. Sorry. That's a b. Okay, so that's what we're going to do. So the first thing we're going to do is we're going to go through and multiply everything through by the least common denominator of x minus 3 times x plus 2. We're going to basically clear our fractions. So we'll multiply everything through. So if we multiply this side by x minus 3 times x plus 2, it completely clears the fractions, and all I have left on this side is 3x plus 11. And then on the right hand side, when I distribute x minus 3 times x plus 2, I'm going to get a times x plus 2 plus b times x minus 3. And this equation is true for all values of x. So the way I'm going to find a and b is I'm going to pick some clever values for x. Now the clever value I'm going to pick are values that are going to make one of these terms go away. So for example, if I let x equal negative 2, that's going to take this term with the a in it and turn it into a 0a. Now let's see what happens if I let x equal negative 2. 3 times negative 2 is negative 6, plus 11 is 5. Negative 2 plus 2 is 0. Negative 2 minus 3 is negative 5. So what I have is a way of finding b. So if I divide both sides by negative 5, I get that b is negative 1. Now let's do the same thing and let x equal a number that's going to cancel the b. So that's going to be let x equal 3. So if x is 3, 3 times 3 is 9, plus 11 is 20. 3 plus 2 is 5. And then 3 minus 3, that gives me a 0b, which I only need to look at. So I get that a equals 4. So we now have our values for a and b, and so I turn this into this integral of 3x plus 11 over, I'm going to go ahead and show you the factored form, x minus 3, x plus 2. This integral that I could not do before has now been separated into what's called partial fractions. So it is now going to be a, which I found out to be 4, over x minus 3. Keep in mind I'm integrating here. And I can do these integrals separately, plus the integral of b, which is negative 1, over x plus 2. Let me extend the page here a little bit. And so now I have two integrals, and I can turn these into perfect little natural log integrals by taking that 4 out in front. And I'll take this minus 1 out in front of the other one. I was missing the dx over here. So my answer to this problem is 4 natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x plus 2. Oh, what am I missing? Plus c. Anyway, let's see that process one more time. Okay, here is an integral, and it's a fraction, and the bottom is a quadratic, and the numerator isn't even close to being the derivative of the denominator. If I let u equal x squared minus 4, my du is 2x dx, and there's no way I can turn this equation into 1 dx, but with that, because I get du over 2x, and they'll be substituting an x in for a dx, and it just gets, you just can't do it. So the trick to doing this is saying, well, it's not u prime over u. I have a quadratic in the bottom, so let's see if we can't do partial fractions. So first of all, let's factor. That's a difference of squares. Some of my pre-calc kids would be shocked to know that. And so we want to now separate this into two fractions. So we say 1 over x plus 2 times x minus 2 can be rewritten as something over x plus 2 plus another something over x minus 2. So let's go ahead and clear fractions. Multiply both sides by x plus 2 times x minus 2. So on the left-hand side, I'm just left with a 1. On the right-hand side, I have a times x minus 2 plus b times x plus 2. So I come up with an equation that's true for all values of x. So my clever little values for x are going to be, let's let x equal 2. So b is 1/4. Then let's let x equal negative 2. So a, that's supposed to be an a there. A is negative 1/4. Alright, so I'll extend my page just a little bit. Go back up. Okay, so I turn this into negative 1/4 over x plus 2 plus 1/4 over x minus 2, and that's what I'm trying to integrate. So let's pull those negative 1/4 out and the positive 1/4 out, and I will get negative 1/4 natural log of the absolute value of x plus 2 plus 1/4 natural log of the absolute value of x minus 2 plus c. Now, something that can happen here is the AP test can get creative, and they can do something like turn this around to factor out a 1/4, and then I'll have the natural log of x minus 2 over x plus 2 plus c. If you remember your properties of logarithms, if you do the log of something minus the log of something else, it's the log of their quotient. And so that does happen on the AP test sometimes. So there we go. All right, well, I will see you guys tomorrow.